H is in pink so that you can follow where they go in the bigger molecule. So now, you know, this reaction, we need a catalyst. This catalyst can be platinum, palladium, nickel, the same thing as the alkenes. I'm hoping that this isn't too troubling because we already have seen a reaction just like this. Just realize that, you know, you have this multiple bond and you're just adding a small molecule across the multiple. Treat this just like you did with the alkenes. Cool. Yeah. So when we look at an aldehyde, it'll make a primary alcohol. When we look at the ketone, it'll make a secondary alcohol. So that's pretty easy, right? Cool. You know, first, before we go on, let me go ahead and open up a whiteboard really quick. Those of you at home, can you see my whiteboard or do you see a slide? Awesome. Thank you, Catherine. All right, great. So I'm just going to randomly draw a molecule. Pick a number. All right. So I'm drawing a really big, gnarly looking molecule. Does this molecule scare you? It does? No. It shouldn't scare you. So if you look at this molecule, you can see how the majority of this molecule is nothing but carbon and hydrogens, right? And what we know about carbon and hydrogens is that they're fairly unreactive. So the only site of reactivity is going to be right here, right? That's pretty cool. So, let me see. I'm going to make it more complicated. There we go. Okay. So here is a reagent. What kind of reaction is this? Oxidation. Okay. So this is definitely an oxidation reaction. In an oxidation, what happens? Okay. Is there a specific place? Can I do this on a hydrocarbon on the ring? Can I go like this? Oh, okay. So I got to do this on the alcohol. There's a specific place for it. So don't let this big giant molecule scare you. All we need to do is redraw it. Okay, so I put the O here. What do you want me to do with this? What am I going to do? What am I going to change? What is the only thing I'm going to change? That's all I'm going to do. That's it. All I'm going to do is add a double bond. So technically that's adding an oxygen?
Or taking away hydrogen, because
Right, okay.
you had hydrogen over here.
Right.
Sorry, let me redraw the double bond, it looks weird. There you go, that's it. So big scary molecule, no problem. Look for the site of reactivity.
So it's either or, so if you end up with two oxygens, you either, if you already have an oxygen, you take away the hydrogen, or if you only have a hydrogen, you add an oxygen?
It depends on how, like, where we are in the grand scheme of things, right? So remember,
Here it's like, I guess I was confused because technically it said if you add an oxygen, I mean, you should end up with two oxygens.
correct,
Hypothetically.
and that would be a little funky.
Right, so that's why I guess I was confused.
So if we go from alcohol to aldehyde to carboxylic acid, this is kind of the ranking in terms of going from something of reduced to something that's oxidized. So the difference between an alcohol and an aldehyde is removal of hydrogen. And then if we go from aldehyde to carboxylic acid, what are we doing here?
You're adding oxygen.
Good. So this is what the schematics look like for something like a primary alcohol. You're not going to have anything else. You're just going to go from alcohol to aldehyde to carboxylic acid.
So oxidation sugars can get like either, but it just depends on if it's flowing from one thing to the other or another thing to the next.
Correct.
So you have a big
Correct. Yeah. Can I erase the top thing, or?
Yeah.
I mean, I can give you guys more time. Okay, big scary molecule. What is the functional group of big scary molecule?
Is that an alcohol?
Heck yeah, that's an aldehyde. This is an aldehyde.
So that's how you know how to name the molecule in terms of like, you know, how to change the parent chain, like the end of it. So if you locate the functional group, you know how to name the parent chain.
Exactly. If you're able to find out what the functional group is, that helps you name the parent chain. Absolutely.
All right, very cool. So let's take a look at this reaction. You've got this aldehyde. You've got H2, PT, and some triangle that means heat. What kind of reaction would you expect here? What's going to happen? Addition of what? Oxygen. All right, so we've got either oxidation or reduction. Check out this like moiety right here, look. And we have one of these and we have this little baby molecule right here. What do you want to do with this?
Does that mean you're adding those two hydrogens? Sure. So you are oxidizing? Or no? Are you reducing it?
Yeah, we will, this is a reduction. This is a reduction by gain of hydrogen because we're adding this hydrogen across that multiple bond. So tell me what the product should look like. Good. Yes, absolutely perfect. So let me show you what, if I put these H's in blue, we've got this H that added and this H that added. Remember, we can add small molecules across these double bonds. This is very, very important to be able to do. It's just like the alkenes. We did this with alkenes. Now we're doing it with carbonyl compounds. Okay, so are you guys comfortable with adding small molecules across a double bond? Well, don't worry, I'm not going to get very far. I'm not going to get very far today. We will spend most of our time on Wednesday talking about this, but I want to make a small introduction. So I just wanted to ask if you guys were comfortable looking at something like this. So we've got our small little molecule like this that adds across that double bond. We have two bonds that are broken, two bonds that are formed. Questions, comments? Well, I'm going to introduce it right now. I'm just trying to get a feel for the room right now.
I guess that means that seems simpler than what's on the problem set. Did you get there yet? Or no?
Okay, let me see. Oh, the very last question?
Yes.
Oh, that's what we're doing.
Okay.
Oh, yeah, that's the big scary thing.
Okay.
Yeah.
Because like those are adding hydrogens, but this is like alcohol.
That's right. Great segue. This is a great segue. So I'm going to go ahead and advance the slide, and let's go ahead and take a look at another addition reaction. This addition reaction is adding another small molecule across a CO double bond. You can think about this as like water. Do you guys remember when we hydrated an alkene, we added water across the double bond? We can add an alcohol across the double bond. So this alcohol is going to be composed of two different parts. We've got an H and then the rest of the molecule. So we've got
R3, R2, what does that mean?
Oh, that's a great question. So let's take a look. The question was, what is the R1, R2, R3 thing? If we look at this, we've got an aldehyde or a ketone. What we know is that R group means carbon. So what this is saying that the R1 can equal, but doesn't have to equal R2. So we can have different lengths on either one of these, like R1 could be an H, R2 could be a CH3, R3 could be a CH2, CH3. So it's just telling you that you can have different R groups, that's all.
So when it's just like R, that's meaning that like whatever the R is the same for all of them, but then if it has the number that it's like different things for each other, or?
No, sometimes books get lazy, sometimes books get advanced.
So it's just not consistent.
It's not consistent, yeah. All right, so let's take a look at this. We're gonna start with an aldehyde or a ketone. Depending on what the R groups are, if one of these R groups is an H, then it will be an aldehyde. If both of these R groups are carbons, then they'll be a ketone. Then we have an alcohol. And if you guys remember what an alcohol is, it is ROH. And this R group can be like a methyl, an ethyl, a propyl, an isopropyl, whatever. It don't matter. Exactly. But we can treat this alcohol as one of those things where we can split it apart. So this is probably like, I'm hoping that this is A-okay. What we're gonna do is, just like in the alkenes chapter, we can break those bonds. So we're breaking the same bonds. We're breaking a double bond, and we're breaking the bond to separate the alcohol. So we've got H as one part and OR as the other part. The way that these add is specific though. So the H is always going to hang out with the oxygen. And that's because oxygen is electronegative, hydrogen is electropositive, and so they're attracted to each other. So now what you have is you've got this OH bond, which is super happy. And on the carbon below, involved in that double bond, this OR3, the OR3 always goes to the carbon. And this resulting product is called a hemiacetal. A hemiacetal is simply a structure that you have an alcohol and an ether attached to the same carbon. So this is the generalized structure of a hemiacetal. What you'll notice is with this carbon,